So, hello everyone. Hello to all the audience. It's exactly 3 p.m., 13th of May, and we will start this webinar dedicated to voyage efficiency and what we can get from AI-driven ship routing and what could be the improvement and the input of AI also on fuel management. Let's first introduce the speaker who greatly accept to be part of this of the panelists and to be part of this webinar. First of all, I want to thank Pasquale Bisogno, which is the Deputy Head of Performance and Decarbonization at D'Amico. Hi, Pasquale.
Hi, good afternoon, everyone.
I welcome as well Lajos Holmslykke, from which is a General Manager at TORM. Welcome, Lajos.
Hello, everyone.
And Siddharth Kishore Kumar, which is a product development at Ascenz Marorka. Welcome, Siddharth.
Hello. Thank you.
And I introduce myself. I'm Alex Stegner, the CEO of AMPHITRITE. Let's start directly. I will start this presentation. So as the title is given, AI-driven ship routing and fuel management, when we talk about AI, it's always, you have to always related what is hidden behind AI is data. And of course, as you know, you have a big move in the shipping industry dedicated to digitalization, and this allows to use AI tool. And there is a different way to introduce AI in the shipping industry, using ship navigation data, for instance, to get better digital twins, better vessel model, also more accurate engine monitoring, or following the performance of the ship, or fouling aspects, but also logistics as well, as the berthing and different aspects of logistics. And this is what is generally the different aspects of different topics where AI plays a role and where we do have data available. But today I will talk about something else, how we can use AI, and also another type of data, which is really at the very beginning of any ship routing, you need accurate, good and accurate and reliable meteorological and oceanic data. And AI can play a significant role here again to improve the quality of this initial data, because with poor weather forecast and poor oceanic forecast, you have not a big chance to have a reliable and efficient routing system. Just to mention that it's very recently, the last few years, 2022, 2023, that a new generation of forecasting model appears for especially weather forecasting. These models were developed by not meteorological centers, by big tech companies like NVIDIA, Google, and Microsoft. And the main results of these weather forecasting systems, that they run 1,000 times faster than the standard computers, because they're using neural networks. So the duration of the training could be very long, but when it's in operation, it's 1,000 times faster. And more than that, the quality and the accuracy of these forecasts is almost the same and sometimes better than standard numerical models. So it's really a revolution that is starting now, today. And at AMPHITRITE, we are in this part of this revolution, but we are focusing not on the weather, but more focusing on the oceanic data, and especially on the ocean surface, what can be seen from satellite observation. And we have a huge amount of data available from different satellite observations. We use state-of-the-art of computer vision to process the different satellite imagery and satellite datasets to provide the most accurate ocean data for specific application. And today we are talking about ship routing, voyage optimization, and also vessel or digital twins. Let's give some example of what type of data we are using as an input in our system. We are using visible satellite observation. This could be chlorophyll. You can see here on the left chlorophyll concentration. But what you can get from this chlorophyll, you see different patterns. You see different filaments, you see different structures, and these are the signature of the oceanic currents. Same time of signature on an infrared imagery, which is a direct measurement of the sea surface temperature. Here again, you see a lot of patterns, different scale. Here the typical resolution could go down to 300 meters, so it's very high resolution there. And at a coarser resolution, you have what we call the altimeters. The altimeters give an estimate of the sea surface height, which is a measure of the sea surface pressure. And combining these different sets, these different type of satellite observation, we are able to reconstruct the surface currents, and not only reconstruct the surface current at the present day, but taking into account the last 10 or 15 days of past observation, we are really able to process a whole sequence, a temporal sequence, and to make a forecast for the next 10 days. And now we are even going on a longer period, up to 30 days, going back to a more climatological, I would say, expectations. And so we have a global product with a global coverage with a relatively high resolution, 3 to 4 kilometers. We compute this with a forecast every hour, taking into account the tides, with a 10-day dynamical forecast up to a 30-day forecast for long crossing, transatlantic or trans-Pacific crossing. Besides, we have 10 years of historical data. And just to give you an idea, just to compute this 30 days of forecast, it just takes half an hour on, let's say, a PC gamer. So a bit boosted, of course, but it gives you an idea of how powerful the AI tool can be today. Why we are focusing on oceanic currents? Because when you ask to ship captains, when you ask to first mate, what are the reliability, what is their feelings, their perception of the quality of the weather, the wind, the waves, and the current, you see that there's a big improvement to be made on the currents. And this is also can be tested on real, on the standard numerical oceanic current forecasting. Different systems give different results. And of course, when we provide a new data set, when we provide this new generation of forecast, we all need to test it, to validate it. And as we are a team of oceanographer, we are used to do that. And we are using different types of independent in situ measurements to check the quality, to check the validity of our forecast. We use surface drifters, which measures the average current on the first 10, 15 meters, which is really the current that impact big ships. We use data from oceanographic campaigns, acoustic Doppler current profiler, but we also use more recently data coming from an analysis of X-band radars, which is a system that is deployed on few ships, and give very interesting and accurate measurements of speed through water and the surface currents as well. And when we compare with the standard, the traditional numerical forecasting of the surface currents, we compare here with the European model, what is directly available today on the Copernicus Marine System Service, what is available on the NOAA service as well from the US. Let's say basically we use different types of metrics. We study this in different areas. Here, this is what is the forecast for the next 7 days, day plus in 7 days. 1 week ahead in the Mediterranean Sea. Basically, when it's deep green, it means that it's very good. And when it's deep red, it's very bad. Of course, when you're forecasting, you have different areas, different places. You can see that on all the cases, both on the angle, the direction of the current, but also on the magnitude of the current. This new generation of data fusing satellite observation really have a very powerful and strong gain in the quality of these oceanic currents. We do the same thing in another area, which is a very energetic area, the Cape of Good Hope. And here again, in comparison with the different standard operational model, either on the direction, the angles, or the amplitude of the currents, we have here again strongly increase the deep green and reduce strongly the deep red, which is the wrong data. And let's give some example. What can we do now with this fine scale and accurate measurements? I give you an example, very quite recent example, where you have here a bulk carrier sailing at 13 knots. In the south, this is the tip of South Africa, the Cape of Good Hope. This is the Mozambique Channel. And this is a very energetic area. You have strong currents there. Of course, you have wind and waves. And here we see on this direct route, the standard route, without any optimization, that you will benefit from the current in a little area, but you will mainly face the currents there. That day, during this week, the waves were not too strong in this area, so the main optimization here comes from how we can play and gain with the currents. And we check now if we select an optimal route, going a bit more closer, a little bit south, and we basically are green all around this new trajectory. So we gain +1 knots in the mean speed over ground for this 7 days duration of voyage, and that leads to fuel gain up to 8 to 12%. It depends on the type of the vessel and the power curve of the vessel. And this is really easy fuel gains, I would say. And this is really the gains that you get on the oceanic currents. We take away the impact of what we can gain on the wind and the wave, because here again, we are a bit in even a better condition for wind and wave following this path. Just so to summarize and to respect the time, since I'm the moderator, I will respect the timing, just to say that AI can provide much higher quality in the ocean data using different fusion of satellite observation. We have today a fast API that can provide all the meta-ocean data, not only the currents, but also the wind and the waves for any solution providers. This could lead to easy fuel gains, a better quality on the routing systems, but also a better estimation of the vessel performance, providing more accurate speed through water when you want to have a good vessel performance model, or just monitoring the performance of the vessel in real time. Just to make a little teaser, as you know, today it's a webinar, but in the coming months, in October, you will have the ship navigation and voyage optimization meeting that will be in person, in presence. So just to say that in Hamburg, Germany, I will relieve some new developments, research and developments that we are doing on wave and current interactions, how the currents can also amplify or change the wave field at a finer scale. And this, you will know all that next October. Thank you very much. Oh, so I will answer the first question. What about the frequency of data update? We have sometimes think that the third party buying their data from a weather data set, an update of 9 to 12 hours. And okay, so the frequency of the updates really depends on what data you are looking. For the wind and the waves, we have an update every 4 hours. And for the oceanic currents, apart from the tide, so for the tide, it's every hour. So when you are in a tidal area, there is an update every hour, well, that makes sense. But when you're in the middle of the ocean, we rerun the model every day, because the dynamics of this oceanic currents is quite small. It's quite slow, I would say. It takes several days to have big change in the meander and the oceanic veins. So usually in 1 day you have little change. We can go down to 12 hours, but of course for wind and waves, weather data, we have an update every 4 hours. And it's the numerical models Standard weather provider in Germany give this every 4 hours, and if you have a supplier that change this only 12 hours, you can find a better supplier. I will let the floor, trying to respect the timing, say 10 minutes of presentation, 5 minutes of Q&A. I see very interesting question. I will try to answer it directly in the Q&A, and I will let the floor to Lajos from TORM.
Thank you very much. Thank you, Alexander. So thank you for participating. I enjoy these seminars. I get a lot of feedback, and this feedback I myself use to further think about new ideas on how we can improve our products for our fleet. So I work in TORM. TORM has currently 91 tankers around the world, all on spot, a few on CC, meaning that we have basically all in-house operation. We have what we call a one TORM model. It means that we have everything, meaning that we have the finance, we have the technical, we have our seafarers, we have our development teams, and then we work quite a lot with suppliers, and we are very, very data driven. And that's also what I would like to talk to you about today, how we use the data from all kinds of sources to enrich our seafarers on board to make hopefully better decisions using better data, which is very much in line with what Alexander mentioned just a few minutes ago. My agenda for today is a little bit about automation, how we automate our daily advices and how we manage the fuel. So it's a little bit practical. It's not so, I don't know, it's not so visionary. It's more a little bit practical on how we actually work with the data on the day-to-day. And a little bit about the future CII and how we see it for companies such as ourselves. We have in TORM spent the major part of the last at least 5 years in trying to develop it's a vision, you might say, a vision on what is it that we would like to see, what is it that we would like to offer to our seafarers and to our office staff. The next picture is a little bit, it's actually very visionary. So it's like, this is our platform. It's an AI picture, but it's actually not bad because that's exactly how we see it. We would like to have a system to use from gathering data from our ships, collecting live data from our ships, transferring data back to our seafarers. It could be in routing, it could be in voyage optimization, it could be in energy efficiency, it can be many different things. And we are maybe 10% on the way yet. Where we started was mainly on the voyage optimization because we were ready with the voyage optimization. We had the data, we could populate the system with the data. We could send advices using our own platform to share with our vessels. So where we are at the moment is that we have almost all of our fleet. We did sell a few vessels recently, so of course they were not equipped with the system. But besides from that, all our vessels, they have access to the system. They are upgraded with the system. We have more than 400 sensors per vessel, and then we use algorithms to detect areas for attention and improvement. Could be in the technical management of the vessel, could also be in the voyage optimization. And as I said, we grow as we go along because we need input from our seafarers as to areas where we can improve. It could be in processes or in sharing the information, which is also the ambition of this project. It is to make sure that we always have the right information and that we can share it at the right moment with the right people in our organization. And as I mentioned, we started up our voyage, you could say, with all the data we had for the voyage platform. And in that, what I mean with that is that we use a company called Optimum Voyage for calculating the most optimum voyage. And what it does is that it avoids the bad weather, but we also build alerts in the beginning. We also do that today. We push these alerts manually to the vessels via algorithms, via emails. Could be that a vessel is in the vicinity of a security area or a safety area, but it could also be high waves. It could also be cyclones. Right now, this is from yesterday, so there are no cyclones right now. It's not the season for cyclone, but as you can see up north in the off the Newfoundland area, we have the iceberg limits. So if a vessel is kind of entering within the close vicinity of the icebergs, then an alert will be populated, and the master is expected to react. If he doesn't react, I will be here to supersee and supervise, but I don't do that much anymore, actually, because the vessels themselves, they have access to everything, so that our colleagues at sea can see what our colleagues ashore can see. We can also populate ECA areas and support our seafarers with these areas, and we can support our operation with the information we gather from these systems. And then the next question is, of course, what is it really that AI offers, and what is AI? AI is split in two. It's machine learning and it's large language models. We mainly use machine learning for everything that we have built so far. We use it to detect. Our primary ambition was actually to avoid incidents and save bunkers. But in reality, what it offers us is also, you could say, it offers some sort of agile ability to scale. Meaning that if we last year, I think we increased our fleet with 32 vessels. And once you have the processes up and running and the data is there, it is. I'm not going to say that it's easy to implement 30 vessels. That's not what I'm trying to say. On the contrary, we have tons of people who are really working hard. But once you have the algorithms up and running and you receive the data, obviously you need to deploy the hardware on board the assets in order to receive the data. But once that's up and running, it is actually quite functional. This agile scalability functions quite well once you have digitalized all your processes, and that is where we are with the voyage optimization at the moment. As I mentioned, we started with the safety. That was one of our primary drivers for building this platform and trying to optimize our voyages, and obviously also to reduce the emissions. So we actually did succeed in that. We have recently actually seen an increase in heavy weather incidents again, and obviously we will then need to analyze where does this come from. One reason could be that the general weather around the world is getting worse, or maybe our passengers are moving around the world so that we are in less safe areas. How it functions, our optimum voyage system, I don't know why it's not really running, but never mind, is that it simply takes it was actually supposed to run everything at the same time, but never mind. It takes the master's route, and then it looks ahead in time using algorithms, and then it will look at the current, it will look at the waves and the seas and the wind, and then simulate the voyage to try to avoid the bad weather areas. And a little bit back to what Alexandre mentioned, that there is actually a significant saving to be achieved by performing this exercise, and we have come to conclude that this is correct. We can also see quite some savings, and the savings are actually coming from avoiding pushing the main engines in bad weather. So yes, you can avoid by currents. I totally agree with that, but you can also avoid by avoiding bad weather, where let's say a conventional vessel might keep the handle in the lock position and then push through the bad weather. We never see that anymore. So we see quite some reductions in the fuel consumptions, especially in the areas where we see bad weather. Moving on, also in the essence of time is sort of our voyage optimization module, is where, so as I mentioned, what you're seeing here is the vessel. It has shared his own voyage plan. It's the red voyage, and then next to that you can see the bended passage plan. The great circle passage plan is then the system proposal. It proposes the master to take a more optimum voyage, and then we present the weather for the master, and then he can make his own decision. We do We would never push a voyage to a master. We invite him to participate actively in the discussion about the voyage, so that he himself can see the benefits on his vessels, because we do not know what's happening outside his windows. We all know that weather can sometimes be incorrect, or the perception of the weather locally, because you're a fully laden tanker, is not the same as what I would think it would be, because I don't have the same experience as our colleagues on board. So we present the optimizations, and then we leave it up to the masters to decide whether it makes sense for the voyage to follow. And then, of course, our commercial business is also interested in this. They would obviously also apply a certain kind of psychological pressure on our seafarers, that if you can save 2 days on a voyage by avoiding the bad weather and save bunkers, then someone might call up the captain and say, hey, why didn't we listen into this? So that's one area where we have actually seen quite a lot of benefits from using, whether you would call it algorithms, or whether you would call it AI or digitalization. It's in my opinion, it's a little bit the same, but of course that can be discussed. A new area we are looking into is the efficiency of the voyage. So it's also about how you manage your power management. So we have spent quite some years teaching ourselves, or learning from the history, learning from the data, on how can we avoid excessive wear consumption transiting the oceans. And as I mentioned, bad weather definitely not up for discussion. We can definitely save bunkers when we avoid the bad weathers. But we have also learned that constant power as a concept is actually something where we, with a fleet of tankers with medium-sized engines, can definitely save something. And it comes from behavior. It is not just, some vessels can just push a button, but if we look at the commercial pressure, and if we look at the behavior, and if we look at our marine masters, then there's a tendency to, in bad weather, then you increase it a little bit, and then you slow down a little bit thereafter, because then you have good weather or whatever. By maintaining constant power in good weather up to whatever has been agreed with our customers, and then reducing speed when it's not required to push the engine, and that could be following the bad weather clauses in our terms with the customers. We benefit. We think the world benefits because the environment benefits. We benefit as a company with the CII. Our customers benefit because we are much more efficient on our assets compared to what we were in the past. What you're seeing on the picture is how the vessel is actually maintaining a constant power throughout time, and how the vessel is maintaining a constant speed. The difference, or the reason why there might be a slight difference, could be because the weather is slightly better or slightly worse in on board the ship, or our whole model is not perfect. And we work with this constantly to improve all the data fields we have from all our vessels. It's a good example, I have to admit, but many of our vessels actually look like this. In the bottom graph, what we see is an attempt, at least from our machine, our algorithms, to calculate what is the vessel consumption versus what is the added loss because of the hull, and what is the added loss because of the fuel. I think something happened here. Just one moment. I'm not sure that was intended. I will just try one more time. Oh, I have just one slide left. That's on the CII. Many that the recent MEPC meeting meant that there is now we now know exactly what will happen to the CII, and our board is very interested in this. How will that impact us as a company? So we try to simulate what will happen into the future with the new regulations from the MEPC update last. And if we take our 2024 results, which are not yet available from and if we try to simulate that ahead of time, even without doing anything to our fleet, we are in a really good position. I know we do a lot on our fleet. We spend a lot of money on we do a lot of investments on efficiencies, but we believe that what we do in the efficiencies and what we do on the voyage optimization and our original platform, our one-ton platform, is a significant contributor to the low CII that we have for our entire fleet. Good. I will stop myself here. I think I spent a little bit too much time. Apologies.
That's okay. We have plenty of time, Lajos. Thanks very much. I will just take one question for the. I've checked. There's a lot of Q&A on your presentation. I think some are very specific. You may answer directly to the audience, but there's one that maybe can concern other panelists. The question on how this routing system take into consideration forecast uncertainties. Because of course, when you have a long time horizon, the impact of the uncertainty is increasing. Do you have any?
It's a big challenge, and we have worked a lot with our vendor, who is Optimum Voyage, to how can we there's really something happening to this screen. I will not touch anything now. So what we have done is that we try to avoid looking too far into the future with the weather, meaning that we do trust the first 7 days, and then we prioritize the first 7 days. Whatever happens thereafter, we try to avoid looking into in our consideration. However, there is also an aspect of seasonality, and seasonality could be the last 30 years or the last 5 years, and then see how the movement across the oceans are from the seasonal perspective. I have that information at my hand, and we actually have PhDs working on this information layer, so that when we start up a voyage, we try to start it up with an historical seasonality layer. And then once you actively are engaged on the voyage, you use the latest forecast to update the voyage. But there are a lot of parameters that you can, I wouldn't say play with, I would say work with, in order to optimize the entire fleet and then learn from your experience going forward.
Okay, thank you very much, Lajos. We let the floor to Siddharth now, and take the time to answer the question directly, and maybe we don't hesitate. We will see for doing the Q&A if we have more time also to go coming back on some of the questions. The floor is yours, Siddharth.
Thank you. Am I audible? Cool. Okay, good. So good afternoon, good evening, good morning, everyone. First of all, thanks to BS Group for organizing this. I think it's been really fascinating so far with the first two speakers, and I'll try and keep up. So I'll kind of talk to you guys about how artificial intelligence is transforming, voyage efficiency, not just through weather routing. I mean, that's become an obsolete term now. It's more of voyage optimization, and then optimizing fuel management as well. So I'm kind of more than looking forward to taking you through how we at Ascenz Marorka, we are part of the GTT group, are leveraging this to address one of the most critical challenges in maritime operations, that is voyage efficiency. And being a seafarer, past seafarer, I think I'm very excited with the way the industry is riding on this digitalization wave that we are in the midst of right now. So as far as the agenda is concerned, it's 4 pillars that I'll base my presentation on. It's 10 minutes, so I'll try and keep the time. So it's voyage optimization, which is how AI is helping us make real-time routing decisions. We've got live ship added resistance, of course, understanding how added resistance, how the condition of the hull and the propeller impacts, point number 1. And then we have machinery performance, and finally trim optimization, which is you could say a hidden lever for really massive savings. So before I dive right into it, a little bit about our group itself, because that kind of is it's important to understand the foundation behind our AI capabilities. The GTT group has acquired a lot of businesses over the years, and Oz Engineering is our Center for Artificial Intelligence. It's a French company based in Paris, and this isn't just about R&D. We are deploying high impact AI applications at scale. So as you can see, some of the customers of our offerings are big companies: Naval Group, Siemens, Safran, Thales, and Siemens as well. So and it's these solutions that get integrated into our weather routing and into our optimization, as well as maritime domains as well. So going into optimization, so I think this really is one of the biggest game changers. Yes, it's a bit of a buzzword today in the industry: optimization, voyage optimization, and fuel savings. But then I think we need to understand that we have moved beyond traditional weather routing now. It's no more a case of we send a list of waypoints to the vessel and then they start following this route. It's more about backing it up with very strong data data sets and proven data evidence. So at Ascenz Marorka, we go beyond static forecasts or just preset routes. What we've built is a decision-making engine that enables the user or the operator, that empowers the user or the operator, I would say, and one that dynamically ingests real-time data. Let's say inputs including weather, ocean currents, engine load, fuel quality, and even tidal conditions where required, and it continuously recalculates the best path forward. What we call this in our platform is something called as the auto refresh function. But what makes this unique is how multi-objective it is. It doesn't chase just one parameter. It balances and optimizes for, we could say, cost, ETA, safety margin, and emission targets all in real time, all simultaneously. It just doesn't target one specific parameter at a time. So the system also learns from every voyage. It refines itself constantly. So the longer it is used, the smarter and more accurate it gets. Of course, you have other inputs like the baseline models as well, which need to be updated, which would get updated over time. But then this is how the system functions. And what this means for ship operators or owners is that there's no more guesswork. So it's just data-backed routing decisions, and you have as and when time progresses, you have tangible savings and better compliance as far as regulations are concerned. So our methodology integrates very high resolution inputs. I mean, that again draws me to a fact that it doesn't restrict itself to high resolution inputs. Of course, we're able to do things from very basic level data as well, which is the case for most of the ships in the water today. So we can integrate everything from satellite rate weather data and to real-time onboard sensor feeds, as well as known data. So these inputs are continuously fed into the platform. What this does is it helps to build a very robust, you could say, algorithm, and it doesn't suggest one or two options, but it runs through millions of permutations and combinations. But then we have a mathematical methodology which helps to deliver results. So coming to the techniques that we deploy. So what truly powers our engine is what's under the hood. So basically the mathematical intelligence behind every decision. We use a hybrid kind of a model of let's say you could say reinforcement learning, stochastic modeling, and constraint based optimization. So basically the system isn't rigid. It learns, adapts, and it improves continuously across voyages and over time. At the core of this engine is what we call a heuristic function, basically a smart decision-making guide that evaluates millions of potential options based on the multiple objectives that have been set. I mean, this could be minimizing fuel, it could be staying on schedule, basically maintaining an ETA, it could be managing risk related to adverse weather, and also maintaining safety margins at all times. So this mathematical model is you could think of it as something like an internal compass for the artificial intelligence that is integrated into the system, and it understands the trade-offs between the cost, time, and operational constraints, and it guides the system towards the best overall decision in each context. So what do you achieve by doing this? You basically achieve double-digit fuel savings, you achieve safety, and you achieve more predictable ETAs, which are very important for commercial personnel going forward. I don't know what's going on. Is it still flickering, or it's stable now?
Seems to stabilize.
Okay. So let's shift to another very key fuel waster. I would like to say, which is basically resistance. It could be hull fouling. It could be a lot of other factors. So I think what's important is this feature that we offer. It evolves in real world conditions. So these are caused by, you could say, biofueling. It could be hull roughness. It could be the quality of the paint on the hull. Its idle periods, the location of the idle period, dry docking gaps, and even port congestion, basically, which would lead to, wow. I think I'm the lucky one that this thing changes on its own. Anyway, so this is why we use real-time. Yeah, we can go to slide 9, please. Yes, thanks. So because added resistance is affected by various factors, we use real-time onboard data and known reports, and in between known reports, basically we kind of interpolate the data to kind of judge what is the effective result of this, and we model the resistance dynamically. So what the system does is it creates a ship-specific resistance profile and not something which is for all cases or for sister vessels or anything of that kind. And this evolves with the vessel's condition and operational history. Over time, this model becomes very, very increasingly accurate. This is what you've seen with our customers and ourselves as well. And this gives fleet managers, superintendents, not only vessel level insights, but also cross fleet benchmarking. So as you would see, the first graph on the right, on the top, basically it gives you a black trend line, which is like the average performance of the fleet, and then there are few vessels below and few vessels above. So one look at it and then you would easily understand which vessels need some kind of adjustments. Maybe some might need a hull scrub, maybe some might need a propeller polish, or any other kind of an action from the operator side before the fuel bill spike, or the emission thresholds are breached, or the vessel starts underperforming. We can go to slide 10 and then subsequently 11. So next, let's talk about machinery optimization. Yes, thank you. So voyage efficiency is not just about routing. So it's about also how you run the ship internally. It's about the technical aspect of it, the machinery spaces itself. So if you can go to the next one as well, you can go to the next slide, please. Yeah. So this use case here is about 2 diesel generators that were running at 44% load. So what our tool did is he suggested one generator at a much higher load, basically 78%, while idling the second one. Now the result that was achieved here is a drop of consumption to about 14.2 metric tons per day, which is about 17% reduction. Now again, if this is scaled over the fleet, and it might seem like a small figure, 2.9 tons a day, but once this is scaled over a fleet, it can lead to massive cost savings or huge OPEX savings, as you may call it. And lastly, we can go to the next slide and the next then. Let's not forget trim. I think this is one of the lowest hanging fruits, as you may call it. You can go to the next slide, please. And this is one of the low hanging fruits. It doesn't require much. All you need is a robust model and a good algorithm, and then you can easily start achieving fuel savings as far as trim is concerned. So we can work basis CFD analysis or see trial data, and understand even how subtle, very small trim adjustments affect resistance and under the different sea states and load conditions. Of course, we pair these CFD insights with real-time operational data. Again, you've got cargo distribution, you've got speed, you've got windage area, maybe for a car carrier or for a big vessel, big container vessel, loaded container vessel. You've got speed, swell direction, and other weather criteria as well. And this way, the optimal trim for the voyage is continuously updated, and this kind of an input is given to the operator as well as to the vessel. Now, this is where our experience as seafarers or in an owner's office or in an operator's office comes into consideration. Now, it's virtually impossible for someone to keep changing the trim every day by ballasting or deballasting 100 tons or 200 tons of ballast from here and there. So you need to use your due diligence. AI and algorithms will keep giving inputs, but then it's very important to know how this is applied practically and how this is used in an efficient manner. We can go to the next slide. So I'm already 2 minutes over time. So to wrap up, I would kind of say, as I said initially, it's no more a buzzword. AI is not a buzzword. Voyage optimization is no more a buzzword. It's something that's very smart, operational, intelligent, and it's very measurable. The results are very measurable, and how we use it is entirely up to owners, up to operators, or charterers as well. And I would say I would just end on this note that there's very little chance. Being a former seafarer, I'm very bullish. There's very little chance that AI is going to replace seafarers all over the world. That's not going to happen, but surely AI will replace those seafarers who fail to embrace artificial intelligence itself. So I think it's very important all of us embrace this change and then move forward, helping us to make smart decisions. Yep. Are there any questions that you want me to take?
Thank you, Siddharth. Yeah. In fact, so I try to see which question are related to your talk. It seems that there is a question on the optimization algorithm when you have a multi-objective optimization, either ETA, fuel consumption, does all these constraints are aggregated into one, I would say, the heuristic function, or are you switching from one to another? Maybe it's a technical question.
Yeah, absolutely. I think this is something that we come across from a lot of our potential customers. So the thing here is there's no use if you just go after one aim and then generate an optimization. So basically, you need to bring in these together. You need to bring them all together. So the first thing that we kind of integrate is vessel safety. We do that because of thanks to a fully functional electro-navigational chart layer in our platform, and then you got the weather layer as well. So you kind of respect the weather, and then you have your objectives for the voyage. Whether you want least fuel consumption, whether you want to get to destination at the fastest speed, or whether you want to go there spending the least amount of money. So once all these three are put together, then the system basically it's capable of giving you a route that matches or that can aggregate all of this and give you an ideal result. Yes, sometimes it's not possible that you achieve all of this in the same time. So in those cases, it will always optimize safety and then weather and then your commercial aspects towards the end. But then, of course, if it's not able to, then what we do is we give you a solution that's the closest to your requirement. I hope that answers. Who's asked this question? Because I might want to reply it.
You can reply also more in detail directly to in the Q&A. Thank you, Siddharth. So
thank you.
Pasquale, the floor is yours.
Yeah, thank you. Thank you everyone for attending, and thanks to the speakers for the good insights shared. So today we are going to speak about voyage efficiency. I will have a cut as per our experience as owner and ship manager. I am Pasquale Bisogno, Deputy Head of Performances and Decarbonization in D'Amico. I am in D'Amico more than 15 years. I was in technical department first, new building, and after with vessel in operation. And nowadays I'm in charge of performance and decarbonization department, always working, let's say, together with the technical department. And as I said, I'm going just to share what is our experience and what is the whole process by applying AI and trying to reduce our emission impact. I put these slides at first just to recover what we talked many times in these last 10 years when, let's say, this decarbonization journey started. Because nowadays, as I see, is more fancy to talk about, carbon neutral and zero carbon fuels, other than reducing, our energy demand. But still, as you can see here, there is a slide provided by DNV, by a research program of DNV. It's very clear how, other than replacing our, let's say, power by carbon neutral fuels, we still need to reduce our energy demand. And this can be done, of course, through the implementation of optimization of voyages. That is our utmost, let's say, consumption in our business. We are covering, let's say, a number of vessels between tanker and bulk carriers of any size. We are managing almost 70 plus vessels. And as department, we also manage 120 vessels since we are covering also third-party management with our international ship manager in Singapore by Shima. So we have a quite big range of vessel analyzed, also different type. So who is responsible for the voyage efficiency? Of course, we are just owner and ship manager, and many times, even though we are going proper suggestion, we believe we give proper suggestion to our customer and cargo owners. Sometimes we need to let them understand where we want to go, what we want to do. And of course, AI in this process will give us timely check, timely information in order to suggest properly in the right time, as Lajos was saying, right information at right moment. This is not always easy, but as I see year by year, also understanding of our customer and charter, especially the big oil majors, is there is a very easy time by time mutual understanding. So I believe that in the near future the things are going better when we are starting a new voyage, when we plan voyage and when we follow up the voyage that is running actual running. So data-driven is a big word, of course, but this will allow to boost our efficiency paradigm, so that is planning, monitoring, and corrective action. We try our best to put our vessel as much efficient as possible. We are also quite lucky in the D'Amico to run a large number of vessels under 10 years, also eco vessels. So we also try to update time by time during dry dock, also with vessel in service, our efficiency of vessel. But sometimes, as we see also with the CII numbers, this is not enough. Because the big part, the 500 pounds gorilla, is taken by operational efficiency, as we have seen with the midterm measures, with the EU ETS, and what we are going to see also with the fuel maritime. So it's very important that not only the vessel is efficient, but also how efficient is the operation. And of course, data-driven will help very, very much in this process. Big data analysis. So what we want to do in the D'Amico is, of course, not just to download a big amount of data, but to download specific data that are helping us to understand how to simulate with a certain degree what we want, how we want to plan the voyage, and how we want to get the results that we have planned. So as you can see from here, also just merging the information that we get from our hull performance and also engine performance, we timely check when is time to do our propeller polishing, our hull cleaning, and also we try to understand what is going on. I mean, also by nature, you know, everybody knows that the temperature of water is increasing. So we are, let's say, managing this process in order to increase. We have increased our DFT of falling of, in order to have more chances during the 5 years between two dry docks, in order to, let's say, to approach more frequently let's say hull cleaning. As well, we are running our engine performance, not only main engines, but also generators, in order to reduce and to keep as much as possible the probability. As you can see, between 2023 and 2024 is shifting on the left. So the probability that we have the vessel in an efficient way is getting higher. And this thanks to the data that we are daily managing. One of the big issues was also to eliminate as much as possible the human error. So we are running 30% of our fleet under sensor data, but the rest is still under non-reports. And what we have seen, we have done analysis in the last 2 years to compare what was reported by captain and what was reported by our weather provider. And most of the time there was a big discrepancy. This because, of course, because of, let's say, commercial reasons. So in order to escape from this process, we have put on board coastal readings of our anemometer that is getting data every 5 minutes. And also we put an accelerometer in cooperation with Partenope University in Naples, in Italy, in order to have the wave spectrum every half an hour. So by this way, we are very close to the reality on what is going on board, to understand better how to attribute our sea margin, and so to know better what is the performance of the vessel. But unfortunately, this is not enough, still not enough. What we see is still emission cost is mainly administrative costs so far. Even though there are regional regulation, as we have seen with EU ETS, what we are experiencing so far with the fuel and maritime. As you can see from bottom graph, still the most preferred optimization, let's say, driver is the let's say the minimum cost of voyage. So regardless what is the amount of emission. So still, you know, even though we are applying many technologies on board, including AI, still we see from our customer that this is still not enough. But what we see from big customers, let's say AI is something that for them is very interesting, but we need to do more as industry, as I believe, in order to give a premium to those companies, to those processes that are applying, let's say, data-driven as the priority while planning the ship routing. Of course, what we know is already clear, and let's say what we try to do is to get from physics of models ship specific models, and this we are doing very fast through AI. So machine learning, data twin, let's say by twin models, we know quite easy and in very fast situation comparing to the past, that we took almost 6 months to understand the specific vessel performance. Now we take less than 2 months. So the things are getting faster. We can give a very, let's say, fast information to our customer. And we have done just this experience recently. I saw a question that was speaking about, let's say, riding vessel for short voyages. We have done this recently by applying B30 on vessels trading between Panama and Colombia, very short voyages, comparing 10 previous voyages and the following 10 voyages. We really got very nice information on which was the speed to fix on those voyages, and we cut more than 12% the consumption, the emission of the vessel by transporting the same amount of cargo. So you can understand for short voyages, less than 2 months, we got very good result thanks to the data that we designed together with our customers. So these are one of the big answers, questions that we are giving at the beginning. We decide as a naval architect and marine engineer, we design ships for specific trade. Why not models for specific business? So AI design is very important. Sometimes, you know, we talk about the AI. Many times I see too much, more than required. But design is sometimes something that is not the first priority. According to me and to us in the MECO, design is taking, let's say, is the big elephant in the room, we can say. Only by building a right model for your specific business, you are able to train your algorithm in order to get better and better, let's say, better model. So what was happening in the past, as per our experience, was to build models and spend the models with our customer just for not enough time to spend models with our customer. Instead now, thanks to the AI, we are able to swap this, and not only for the vessels that we are operating nowadays, but also for future projects. Just let's think about new buildings. Thanks to the data that we are acquiring nowadays, we are able to understand which new technology to apply on new vessels. Just think about wind assisted propulsion system, same power, wind, but different technologies. Just knowing what is your emission process, so you understand which is the best technology that is interfacing with your specific trading. Of course, challenges are there. The first one is cybersecurity, for sure. So we are talking about safety. The selection of a reliable partner and software. Just here we have 2 software vendors, let's say, and sometimes it's not easy also for us to understand which is the best that is going to match with your processes. So this is the reason why sometimes we prefer to do our own in-house processes, Lajos was mentioning. But sometimes we need also help from outside, and for sure interfacing with our partners and verifiers. Cost considerations are there because this process is not for free, no free riders in this process. But for sure, in the long run, who comes first, for sure, we'll get. We strongly believe that we'll get a premium. At the last, we don't have to forget that on board we have, let's say, we have seafarers. For sure, the improvement and training of personnel is very important. We see very much interest from new generation. Resistance is there. We are a traditional business, so we know that resistance, especially from let's say old captains, old chief engineers, but we see that if they understand what we want to do, and again, when we speak about design, so they like to collaborate and to be part of the ship routing, let's say. So voyage efficiency is a necessary step forward for decarbonization, that's for sure. So this will reduce our emission over time, reduce fleet dependency on renewable energy that, as all of us knows very well, in the near future will be very costly. So for sure, the help of voyage efficiency will reduce these costs and improves for sure the market value of the asset. That with a capital intensive industry where we are here, for sure, bringing our vessels sustainable for at least 10-15 years, it's very important. And good understanding of your emission will help for this process that, according to me, will be a long one, still a long one. Thank you.
Thank you, Pasquale. So I can suggest there's the first question, and maybe we can jump on other question more generally in the Q&A part. But there's one question: how do you manage data validation, especially when you handle big data?
This for me?
Yes, I mean, apparently this is a question which was
actually
during your talk.
Yeah, we have a quite large team in Mumbai that is following data. So we are doing data validation on daily basis, basically. So what we do is matching our data with data coming from our digital twin and from also weather provider. So once we decide that the data has to pass, the data is for us is validated. And of course, we like, in order to understand how much the data can contribute to the analysis that we are doing, we set up a variance. So when we give our data to our customer, that let's say our operation department, our chartering department, for sure we like to give that to them, also to let them understand on how big amount of data we are basing our let's say our information. And on top of that, we also give information regarding half hauling, for example, for how long this data will last. So since we have a projection, let's say, of half hauling degradation, we also give to them information until when this data will be valid. Of course, once the vessel will stop for 15 days in, let's say, in Brazil at anchorage, for sure this will impact the data that we just gave a few weeks ago, and we have let's say data analysts that are informing the customer in order to update every time the data that we are acquiring every day.
Thank you. Maybe I will put a question that everyone can answer or try to answer. The expectation of the fuel saving range, but and more precisely, how accurate is the predicted values versus the actual values that is predicted? And this is related, to this very first question on data validation. It's not so simple to validate the fuel gains on a single voyage because you never have two times the same ship, and one taking the optimized route and one taking the regular path. Do you have any procedure, way to do that?
Actually,
who wants to start? You want to start to answer the question, Pasquale? Yes.
Just recently, we have applied a new system that is given by the maker of managing control. So this system, as was mentioned by Lajos, is just giving advice to captain when it is the time to go and when it's the time to keep the maximum fuel consumption and maximum power. So when the weather is bad, of course, you try to save fuels, no need to go faster, let's say, but when the weather is good, let the vessel go. And of course, we have a projection of routing, so we know, we foresee what is the total consumption at the end of voyage, and of course, you just change, let's say, vessel speed. When we talk about vessel speed, we just set the knots of vessel, not RPM, through this system. And once the voyage is completed, we compare projected with actual. And most of the time, we are, of course, we are getting better. So sometimes we are talking about 2 tons, 3 tons, 5 tons. But in the end, when we are talking about 70 vessels, we are talking about very big amount of saving fleet-wise. So let's say nothing is magic, for sure. But this system are helping captains very much, for sure, to improve the culture of saving and doing better performance during sailing.
If I may add a comment?
Yes, please, Lajos.
I completely agree with Pasquale. If you do a standard tabletop exercise and look at a shall I say a normal fuel curve for a standard MR class, which is it's a 50,000 ton vessel in our fleet, if it's in Laden, and if we with our model then try to estimate the fuel consumption in Buffer 6 versus Buffer 0. I know Buffer 0 is not possible, so this is purely a tabletop exercise. So just bear with me. There is a little over 30% fuel consumption increase in Buffer 6 versus Buffer 0. It's an impossible exercise. Of course, you will lose time, so you also need to calculate that into your formula. But very, very often for our MR class vessels, when we are in really bad weather, we are not really getting anywhere. We're just pushing, and we're not getting anywhere because our speed drops significantly. We easily lose 4, 5, maybe even 6 knots, depending on the wave direction, while consuming up to 33% more bunkers in doing so. If you stop or reduce your speed to save steering and then wait for the bad weather to pass and then continue your voyage, yes, you have lost some time. Obviously, you need to make up for that unless your charter party terms allow it. Your TCE will be changed. I agree with that. But if we only look at the fuel benefits, it's significant savings for a voyage if you are in the bad weather season. Then the rest of the season you will not harvest that benefit. So it's also a difficult estimate, but it's just an example.
Yeah.
Siddharth, do you have some comments how you can, when you estimate a fuel saving of a given percentage, how we can validate that? This is always a tricky question.
I completely get it. So this it kind of is easy when you're using it depends on the type of data that you're using for a particular vessel or class of vessels. We have these high frequency data or high frequency data vessels where the validation is more or less quite instant. When I say instant, I would still say about 1 or 2 days or 3 days of steaming, and not hours or minutes. We're not speaking about that time frame. But if it's on a larger on a macro level, I would say we have certain tools or modules in our platform which basically what we do is we kind of build a very close digital twin to the vessel, and this digital twin basically moves in an exact same path that the actual vessel is moving. And then what we do is over voyages we compare how these two are kind of comparing performance-wise, consumption-wise, and all of the other parameters, and the baseline itself is kept updated. But then simultaneously you also have to track what's happening in the real world. So this happens on the basis of noon reports, commencement of sea passage to end of sea passage. I mean, these are the practical things that I'm kind of describing here, and over time you get to a point where you become very close. And then I think the biggest thing here is to ensure that the vessels are following the recommended the recommended suggestions. I mean, they need to follow what we're telling them in a very close manner at least, and to achieve that, I think the biggest factor here is your weather accuracy, because there's no point of suggesting whatever you like, and then if you're going to suggest a 2-meter wave height Beaufort scale 4 and the vessel is facing something like let's say Beaufort 6 or something like that, then there you go, everything goes out of the window straight away. So I think that's the most important factor, and then of course your safety and all of that comes in after that. But then it's more of a long-term idea, I would say, comparing how your suggestions and the actual real life is functioning for a vessel. But yes, it's I think we are still in taking infant steps towards this. But yeah, it's possible, but it requires patience and team trust, and you need everybody pulling in the same direction here. That's very vital. Yeah.
If I try to summarize mainly what you are saying, that we can in fact validate the vessel model because you can check what is the actual consumption and what is the predicted consumption. But the key thing that you won't be able to check, especially for a long crossing, is the weather forecast, and if there is any change in this weather forecast, that you may not have chosen the optimal route, and you are still fighting and struggling with the quality of the weather there. And maybe jumping up on another question that was asked also on the data, there was a quite general question on which is related to AI. Assuming that somebody who is an expert in AI but is not in the maritime sector, is there the source of data set that is used? And is there any open source of data? And that's a critical thing. And as far as AI is concerned, in experience in the maritime industry, it's not simple to have an open access to the data, especially to ship navigation. And there's also a question of building generic data or simulated data. I can answer on that for the weather because it's interesting. But more generally, we can come back on this question of data. But the question on the data is when you want to have a good vessel model. Pasquale, you mentioned noon reports. Siddharth, you mentioned high frequency data. Do we always need a high frequency data? Is there in between? Do you have any suggestion or any idea or results on what could be the accuracy and how the amount of the data, the frequency of the data increases and improve the vessel model in that case? What is the most critical?
But according to me, of course, the future will be sensor data, that's for sure. So sensor data will require, let's say, we cannot say big investment, but investment is there. And of course, you need to set up, let's say, a system of sensor data that is in line with your specific grade. Because many times I see that, many players are putting as much as they can on board, but sometimes it's useless. You just need to set up sensor data for your specific business. And I believe that in order, especially to foresee what is the impact of new technology on board of your future vessels or on the vessel that you want to run in a different business, for sure you need sensor data. So only known data, it's not enough because the weather is changing. And Alexandre, you know very well, the weather is changing very fast. Even though maybe the road is changing 2-3 times, let's say in a day, maybe less. So the weather is still changing very fast. So known data will be not enough. And in many cases, as I've shown in my slides, is not matching on with the reality of facts, at least with our, let's say, new devices that we put on board, accelerometer, as I was mentioned. So what is reported by captain, what is weather, let's say, forecast informing, is not matching with the actual device that we have on board. So for sure, having sensor data with a high frequency, it's very important. And we done, we have run some case study analysis with our, let's say, our reference vendor for wind assist propulsion system. As I was mentioning before, same power, but we have different, let's say, type of technology. Suction sail, rotor sails, traditional wind. Anyone is acting in a different way, in accordance with your trade, with your route, how the wind is impacting your vessel. So without, let's say, high frequency data is completely useless to approach this kind of analysis. So for sure, sensor data will help very much.
Lajos or Siddharth, do you want to add some comments? Or?
No, I agree. Pasquale mentioned accelerometer data. We try to learn when we have an accident, and if you do not have the data, then you cannot learn anything. Then yes, you can try to look at the forecast model and see how the weather was, but you cannot learn what happened, and you cannot. I mean, one vessel, one incident, they will learn a lot. But if you have a fleet, then you need to gain this data in order to avoid getting yourself into the same situation again. And you cannot write a story to a captain telling him that, the vessel was proceeding in the Bay of Biscay and he was proceeding northwards and there were southwards waves, and then suddenly this happened. I mean, I have also been there on a real ship where we lost a lot of containers, and this also happens. But if we want to learn from it, then we need to have the data sensors and then to understand exactly what happened. And only then we can set up our procedures to avoid the same incident from happening one more time again. And for me, this is key. I mean, safety is I'm a seafarer, so safety is everything for me. So if I don't have the data, then I cannot, I cannot use it going forward to avoid the same thing from happening again. And this is just one area. This is a very good example because it's a clear example. That's just, it's not just, there's no just in that. It is safety. If we talk about avoiding, excessive fuel consumption, it's a little bit the same. If you don't have the data to understand why you had the excessive consumption, then you cannot change your procedures to avoid the same thing from happening again. Can you use known data? To some extent, yes, of course, to validate if your model is correct if you don't touch the handle. We see too often that we get 24-hour data as a single data point, but then what happened in between the 24 hours is up and down and up and down. Then it's not a good data point. So if you have a good discipline and if your colleagues at sea, they have very good discipline in the reporting, I do believe that known data can be used. But I think that live data is giving you a new layer of visibility to what is actually happening, and then you can better understand.
Siddharth, do you have?
Yep, I would kind of tend to agree on that since I started the topic here. But there's just one thing that I want to add. I mean, it was summed up already very well by Pasquale and Lajos, the entire discussion. But I would just one thing is even high frequency data has its own set of drawbacks. Sometimes, I mean, you need that data has to be cleaned. It has to be, you need to have a robust data cleaning process, data mining process. So, yeah, if we've seen instances where it makes a complete mess, high frequency data, and sometimes you end up delivering suggestions or results which are very, very how I would like to call it is very not real life, very impractical to follow. And then the root cause of this is because of bad data. So along with this high frequency data comes this other comes the other side of the coin as well. So that's something that needs to be tackled very carefully as well. Yes. But then otherwise, at any point in time to make good decisions, robust decisions, yes. The more data you have, the more data points you have, you can make very certain decisions. But then yes.
So that's interesting because basically adding more data, you still need to add more humans to clean the data and to have the expertise of checking or to validate this data at some point. So AI is not totally replacing humans there, and
exactly.
I totally agree with the fact that you really need to have a human look and to have some procedure to clean out the data before using them, even if it's high frequency, because if you take all this bunch of data, put it all this in the black box, and then you may have very bad surprise at the end. Definitely. And just to mention on the first question about synthetic data, is it possible to build synthetic data? Just to say that when in our situation when we are using a somehow different also source of data, which are satellite data. So all the satellite data, most of them are open source data. So if somebody wants to develop some AI model, it's possible. You just need to have some experience how to process this data at the end, because we are talking about massive data there. But it's possible also to build synthetic data, so satellite observation. This is a bit more tricky, but this is something that we are doing a lot. Doing some, we start with, we call this observation system simulation experiment. So we mimic what a satellite would have seen on a real numerical model, but then we have the ground truth and we can check that. Nevertheless, at the end, we always need to make a training and make several trainings on real data, because otherwise you can fine-tune a model on something which is purely synthetic and it doesn't work. It can be useful at the beginning to do the first stage of training, but at the end you really need real data. And I think this is a real issue, to maybe have an open source of data and to have data sharing between different companies, because many companies are keeping this data for them, and at the end it won't benefit to the whole industry. And since there's a huge amount of data to be processed, we will all gain, I would say, to have an open source of clean data set. Maybe totally anonymized, but this could be very important to do training, to test models, to develop new models, and to do new way of more accuracy in the training. Well, that's my suggestions, but I will see how the industry will evolve in this general sense, sharing this type of data. Try to catch maybe one last question in the audience. You mentioned something interesting, Pasquale, on the data, on the accelerometer. I mean, some kind of direct measurements of the waves. This is something which starts to be. This is also quite important. We do have some data on currents. We do have some data on winds, but the accuracy on the waves is a bit more critical. You mentioned accelerometers. There are other systems, and especially you mentioned also the wind-assisted ship propulsion vessel that will need, which is even more sensitive, I would say, to the weather, the winds and the waves. What is your personal experience? I mean, maybe Lajos and Siddharth of using different type of sensor data, measuring waves.
Yeah, actually, the accelerometer in cooperation with the University of Partenope in Naples, it's a process that we just ran a few months back. Basically, it's giving an average of waves every half an hour. So we have let's say the first goal for us was to understand whether the reporting from ship staff was properly done. And of course, this is helping us on a frequency of 30 minutes to understand better what is the condition under which the vessel is performing. So this, to better, analyze data, to better advise also our clients, because our difficulties, in the recent past, was also to justify some underperformance of the vessel. So, because as we see, especially as I was mentioning before, the same tools that we are running are also under the management of our clients. So likely the culture is improving. So sometimes we go also in details, and for sure this sensor that we are adding on board are helping us to have a better idea on what is going on. So for sure, increasing the knowledge also on board, let them understand that we are having a possibility to analyze data by data. Also, we are giving an additional tool to the ship staff in order to properly report what is the real condition of the vessel, of the voyage, let's say.
Siddharth and Lajos, do you have any suggestions for what would be the best sensors, or what would be the new sensors, what would be the most efficient sensor to get the waves and maybe other parameters that are missing today for having the most accurate AI model or digital twin of your vessel? A difficult question.
I think there's a difference between hindcast and forecast. So forecast, I have absolutely no idea. I'm not a meteorologist, so that would be up to someone else to decide. But hindcast, if we mix the accelerometer motion sensor together with the hindcast data we have from the Weather Institute, we as a company, we actually use that for our customers, so that, let's say we have a claim or it could be a speed claim or performance claim or whatever, then we actually have the data available so that we can use that proactively towards our customers to benefit ourselves. So that we do, and that is, it doesn't have to be, it does not have to be advanced. It can be a normal hindcast system from an API, combining with the accelerometer from the vessel, and then combine these two data sources, and then you have it available. We have made sure that our seafarers also have that available, so they themselves can defend or discuss with the customer. If the customer, as an example, is asking why we're not able to make the speed, and we can document the weather, and we can kind of prove it with our accelerometer from the vessels. But it's very low key. This is not high tech. This is just using the data that we already have.
So, but you need to combine sensors with model data, hindcast data. I mean, when both are in agreement, you said, okay, it's validated. But when it's not the case, is there any one of them? Do you rely more on one of the other ones, or? That's a tricky thing. I mean, we are all facing these issues.
Now you're getting political.
No, it's just your personal experience.
Yeah. We do have a tendency to see that our systems provide more accuracy compared to the manual reporting, I have to admit. But there can be many reasons for that. So we do it kind of as a control measure, but we also kind of use it for many other things. So I mean, legally there's the logbook, and that's always the manual report. So you have to, you're obliged to use that still.
And Siddharth quit us, unfortunately. You're back. Do you want to finish this Q&A and having your input on this question of the best IoT sensor?
I'll be very honest here. That's a bit too technical for me, so okay. I don't want to get into that.
No problem. No, it's just because I know that Ascenz Marorka, you are also have some expertise in this type of sensor. So I was wondering how we can go more and having more and more data, and especially for the new wind-assisted ship propulsion vessels that starts and that are coming, that will be there in the coming years, and we will need probably more and more. We'll have new sensors and new data and new tools to to have a better estimation. So I think we are on time. Thank you to all the panelists. Thank you, Siddharth. Thank you, Pasquale, Lajos, for this very nice presentation, very insightful, answering all the questions. I see that you make a lot of efforts answering to all the Q&A. And a great thanks to the audience who asked all these questions and who stay with us till now, 4:30. And I hope you will join the other webinars, and especially the next ship navigation and voyage optimization that will be held in October, I think 6 to 7 in October in Hamburg. Thanks to BS Group as well. Thanks to Cameron Yusubov who organized all this webinar. And thanks you all. Have a nice day.
Thank you. You too. Bye-bye.
Thank you.
Bye-bye.